Right now, somewhere in your body, cells are dying. Quietly, constantly. You don't feel it, you don't notice it. But death, the real kind, the kind that ends a life, is not a single moment. It's a process. And the first hour of that process is stranger than almost anyone realizes. You've probably pictured death as an instant, a light switching off. 1 second you're here, the next second you're gone. But your brain doesn't agree with that story. Neither does your skin, your blood, or your muscles. They all die at different speeds. Some parts of you can survive minutes after your heart stops. Some parts start shutting down before it does. Here's where it gets strange. In 2013, a neuroscientist named Jimo Borjigin at the University of Michigan placed electrodes into the brains of dying rats. She wanted to know what happens to brain activity in the seconds after the heart stops. What she found surprised her. In the 30 seconds after cardiac arrest, the brain didn't shut down quietly. It surged. Gamma wave activity, the same kind of brainwave linked to conscious awareness and vivid perception, spiked dramatically, higher in some measurements than during normal waking life. Your brain, in other words, may not fade out like a dimming light. It might flare briefly one last time. Nobody knows exactly what that flare feels like, or if it feels like anything at all. But researchers studying human cardiac arrest survivors have found something eerily similar. Sam Parnia, a critical care physician at NYU who has spent over a decade studying resuscitated patients, has documented cases where people report vivid structured awareness during the period when their heart had stopped and their brain should have been offline. Parnia's aware studies don't prove consciousness continues after death, but they do suggest the boundary between alive and dead is far blurrier than a single flat line on a monitor. So what actually happens physically once the heart stops for good? The first change begins almost immediately. Blood stops circulating. Oxygen stops reaching your cells, and your cells, which have spent your entire life burning oxygen for energy, begin switching to a backup system. It's inefficient. It produces waste products your body can no longer clear away. Within minutes, your cells start to poison themselves from the inside. Your skin is often the first visible sign. Within 15 to 20 minutes, your body temperature begins to drop, roughly 1.5 degrees per hour at first, a process forensic scientists call algor mortis. Cool the room and it happens faster. Warm the room and it slows. Around the same time, gravity takes over a job your heart used to do. Blood is no longer being pumped, so it starts to pool. It settles into the lowest points of the body, drawn downward the same way water finds the bottom of a container. Within 30 minutes to 2 hours, this pooling becomes visible as a deep, reddish-purple discoloration on the skin. Forensic investigators call it livor mortis, and they use it, along with body temperature, to estimate how long someone has been dead. If a body is lying on its back, the pooling appears along the back. If a body has been moved after death, the pattern won't match the position, and that mismatch can tell investigators a body was disturbed. Meanwhile, your muscles are entering their own private process. Contrary to what most people assume, muscles don't go rigid immediately. In the first hour, they actually relax completely. This is why bodies found shortly after death often appear soft, loose, almost sleeping. The stiffening most people associate with death, rigor mortis, doesn't typically begin until 2 to 6 hours later, as calcium floods into muscle fibers and locks them in place because the cellular machinery that would normally release them has run out of fuel. But the story inside your body during that first hour is even stranger than the story on the surface. Your brain cells, deprived of oxygen, begin a process called excitotoxicity. Without oxygen to fuel their normal function, neurons start releasing a flood of glutamate, a neurotransmitter that in small amounts helps you think, learn, and form memories. In this flood, it becomes toxic, overstimulating neighboring cells until they, too, begin to break down. It's a kind of cellular chain reaction, cells essentially damaging each other on their way out. And yet, not everything dies at the same speed. Bone and connective tissue cells can survive for many hours. Skin cells can, in some conditions, survive and even be viable for a day or more. This is part of why organ and tissue donation is possible. Corneas can sometimes be donated up to 12 hours after death. Skin and bone tissue can be recovered even later. Death isn't a door that slams shut on every cell at once. It's more like a building losing power floor by floor, room by room, some lights staying on far longer than others. This staggered shutdown has been studied by forensic pathologists for over a century, going back to research in the late 1800s that first documented the timing of livor mortis and rigor mortis in systematic detail. Modern forensic science, including work done at body decomposition research facilities, has refined these timelines using thousands of documented cases, turning what was once guesswork into something close to a predictable biological clock. So why does any of this matter to you, alive, breathing, reading this right now? Because the process happening in that first hour is, in a strange way, a mirror of the process happening in your body every single day. Your cells are dying and replacing themselves constantly. Your skin sheds and regenerates. Your gut lining replaces itself every few days. Even your neurons, once thought to be fixed for life, are now known to regenerate in certain regions of the brain. You are, in a very real sense, in a continuous negotiation between death and renewal, just usually a controlled, gradual one instead of a sudden one. There's something clarifying about understanding death as a process instead of a switch. It means the moment someone stops breathing isn't necessarily the moment everything about them disappears. It means the line researchers and doctors draw to define death is, to some extent, a practical decision as much as a biological one, chosen because somewhere a line has to be drawn. And it means that the fear many people carry about death being instant and total may not fully match what the biology actually shows. None of this makes death less real. Nothing here suggests some kind of secret second chance. What it does suggest is that death, like almost everything else about being human, is messier, slower, and stranger than the tidy story you were taught. Right now, somewhere in your body, cells are dying. Quietly, constantly. And somewhere else, just as quietly, new ones are already taking their place.